and craziness. We are going to ignore all of the buzz and craziness, and we are going to focus on the technical side and see what has actually happened there. So hopefully we are going to have a fun discussion. So if you're less familiar with these sessions, the format is such that we spend about 20 to 30 minutes presenting a topic, and then we spend the rest of the hour usually discussing that. And the goal is for this to be more discussion driven, obviously, because of the topic as well. So as we go, feel free to drop any questions, any comments you have about what you see on the screen in the chat as well, so we can have some discussion going on there. But at the end, we'll also have a live discussion with all of us. All right, Percy, it's all yours.
All right, so thank you, Amir. So hello, everyone. My name is Percy or Bochi, and today the topic, as you can see from the screen, is about DeepSeek R1. So the target of the initial presentation that I want to bring is really just to give you a technical overview of what happened, and basically get you started of thinking, get more clear of what it's about and why people are so excited about it. Then we'll go into a more deeper discussion in different aspects around this topic. Quick introduction about myself. So I'm a PhD student at McGill University. My main research topic is basically centered around building reliable artificial intelligence applications. Of course, I'm also looking into large language models. So I also have active collaborate with Amir and Aggregate Intellect on my spare time. I also, not really spare time, but part-time, also a research associate at Huawei Water Research Center. But enough about me. The main character of this talk is DeepSeek R1. So as you can all see from, I guess, less than a week from now, nobody really really recognize the term too much, DeepSeek. But now you can also say that, basically starting from last week, we're seeing a crazy trend, as you can see from this blue line, of increasing search term on DeepSeek, showing how interested people are getting. At some point, people's interest in DeepSeek actually overpass ChatGPT in some time of this week. And of course, all those big names in AI like Yang LeFen and Sam Altman, they are also very shocked, excited, or interested in this topic and give their comment about it. But why is so much noise about it? Isn't it just another LM, right? So there are a lot of different aspects that contribute to this shock or to this trend that people are so interested about. So that actually the number one reason, I think, is that it's open source. Right? If it's a closed source model, it wouldn't be people wouldn't be so interested about it, because it's open source. You can try it out yourself. Actually, there are a lot of different versions of it. We'll talk about it later. You can even try it out in your phone, which is the benefit of open source. Of course, it's very cheap, as they claim that they are about 90% cheaper than what OpenAI is doing training and inference. So they did a lot of job to actually optimize the model for cheap inference and training. That is really a big milestone in terms of large model hosting and the training. Of course, another interesting part is the reasoning capability, right? Because for now we have a lot of different open source like models, but all of them are still limited in their reasoning capability. So this is actually the first stronger enough open source reasoning model that we can have right now, and everything is open source, including the model itself and the training procedure, where people can actually learn from and play around with. And at some point of this model, we'll talk about this soon later, that part of this model is actually unsupervised. We actually don't actually need to give a lot of annotated data at some part of this procedure, and model learns to reason or think by itself. And that's also another interesting aspect. But the overall idea is that we have seen, starting from ChatGPT, we have seen a lot of different improvements, at least in the open source community in LMs. But all of them actually mainly focuses on, okay, getting the model bigger, right? Getting more compute power and everything like that. And this is one of the few examples where I actually see more like innovation in algorithms and the architecture of the model rather than actually getting crazy hardware to make this model larger and larger. So a quick overview of what I'll quickly say in this talk is that we'll briefly talk about the history of DeepSeek model. So it doesn't come from nowhere, right? There's a history associated with it. We'll see how this R1 model is different from other LMs and high-level idea behind this R10 model and the R1 model for a reason. And we'll say one math, which is 1 + 1, literally. I'll say quickly. But what will not be covered due to time and the depth of this topic, I will not go into detail of the transformer architecture or the reinforcement learning process. And they also have a lot of different optimization strategy like hardware optimization and so on to make this model cheaper. That by its own can actually be a series of topics that we can talk about. And of course, we will not say very crazy math in this talk. So everything should be a high-level idea of just letting you know what happened that makes R1 so different from other LMs, open source LMs that we have so far. Okay, so we talk about R1 a lot. I guess you all heard the term R1. People talk about different aspects, good, bad things about R1. Oh, sorry, about DeepSeek. But DeepSeek is not really a model, right? DeepSeek is just like OpenAI is a company. And when we're referring DeepSeek, we're referring a series of models. And these are actually, the R1 is actually their fourth iteration in their LMs. And we can see a big picture of how they actually get to there. So at some point in 23 or 24, they published an LM called DeepSeek LM, which is basically yet another open source LM, just like Llama, like QN, which really no one cared about. Then at some point, they improved this DeepSeek LM with mixture of expert, which is a method that lets you don't use all the neural activations when you ask the LM to do something, but only parts of the neural network inside the large model is activated, which makes the inference much faster and training much faster. And this is also the time where they use this multi-head latent attention. Just a quick summary, this is basic idea so that you can reduce memory usage in the LM. And this is the first iteration where they achieved very efficient training. So by doing those two things, they actually achieved almost 42% reduction in the training cost compared with their first iteration. Then I think just around a month ago, they got to DeepSeek V3, which first time they actually introduced reliable floating point A training. So for you, any of you that's not very familiar with this term floating point, so basically we store weight of the language models in the computer as floating point. And because floating point, you can actually have a different precision of it. So floating point 16 is normally the one that people use to store a large model weight, which is quite precise enough, but it can also be large. And floating point 8, it saves a lot of space, but it can also, but people haven't started using it so far because it's not precise enough at some point for some operations. But they were able to achieve quite stable floating point 8 training, and that also contributed to a lot of this saving cost. And you probably see some of the news posts claiming that DeepSeek models cost about $5.5 million. And when they say $5.5 million, they actually referring this V3 model. So it's not yet the R1 model. So this is the 5.5 million LM. And after that, so just about 2 weeks ago, they published DeepSeek R1, which is actually the model that get all people so excited about. And sometimes people call it open source R1 because it's so close to its performance. And more interestingly, some partially of this model, it purely uses reinforcement learning without any manual effort, a lot of manual effort at least. So the first 2 iterations of DeepSeek model, that's basically the model what we refer as chat model. So it's no difference from in terms of the functionality. It's not really different from GPT-4 or GPT-4o where you're probably using every day. But it's DeepSeek R1 is actually the reasoning model where we have a similar ability of reasoning as O1 we have. And we talk about DeepSeek and all the noise about DeepSeek, we're really referring to about this change from DeepSeek V3 to DeepSeek R1. So next, let's look a little bit more into detail and what happened in this process. So if you're familiar with LMs and LM prompting, you know so far we had do something similar kind of reasoning already with a lot of open source models, long reasoning models, which is idea that, okay, we can probably provide the model the examples when you use it. We try to ask you to do to answer a question. You give some example or hints to encourage it to think before it output the answer, right? So this chain of thought prompting basically asks the model to give a step-by-step reasoning before it comes up with the final answer. Or this self-verification idea that once the LM output the answer, you ask it to verify, oh, is this answer correct? So far, we're using this with prompting. So we use existing model and give it the hints on to force it to reason and to verify itself. And this idea here that the team at DeepSeek thinks about is, okay, actually, can we try to incorporate this idea in this training as well? So we get a model that actually trained to do this purpose, and then naturally we would expect it to be better. So what they do is they take this DeepSeek V3 based model. So basically, it's a model that's only pre-trained with a large amount of data. So they haven't yet fine-tuned for chat. So that's the base model, and they would this basically gives their first attempt to get what we call the DeepSeek R1 zero model, and they will learn the term zero in a moment. So the approach they have is, okay, we want to have the model to have reasoning capability, and a very good idea to train this reasoning capability is basically use reinforcement learning. So what they basically use what they call reasoning-oriented reinforcement learning. So they set up this scenario for the LM that encourage this LM to, during the training process, to write some thinking, in some thinking blocks before they output this answer. So that's their setup. So they want to use a reinforcement learning to train a model that would produce some think block before they output this answer block. Then the challenge they are facing right immediately is basically how can we get feedback to this model? Because now, assuming that we have some model that we are training in progress, we have an input question, and now the model can give us some reasoning. Maybe at the beginning, the reasoning will be nonsense, and some answer which doesn't make sense as well. And the problem is how we can use this reasoning and answer to provide feedback to the model to basically iterate it, to ask itself to improve itself. So some of the existing approaches on this one, this kind of setup from existing literature, or they are actually one of their failed attempts, is maybe we can take reasoning, right? Reasoning is very important because if you, as a human, if I'm like doing something, if I'm thinking something wrong, maybe I would just naturally derive inconsistent answer or wrong answer. So I think, so at the beginning they thought about, oh, let's focus on teaching the LM how to think, right? So in some sense, maybe we can try to train another model to evaluate how good the LM thinks about this, how good the thinking process for the LM is. And then we use this reward model to reward the LM if it thinks the thinking process is correct, or penalize this LM if the thinking process is incorrect. However, they immediately get some problem. So we're not talking about a game, right, like Go or chess, where we very easily we can define what is a good process. Or even sometimes it can be very tricky to know what kind of reasoning is correct, right? If you have a math problem, there are different ways to come up with the same answer. Even say if you have a programming problem, you write a program to satisfy like a difficult question, there are different ways to basically think about how you can get up to that answer. So that's the first question. They say they really don't know a good way to define a correct reasoning process in general. And the problem with training a reward model is also that, right, you need to have a good reward model, then this training may be as expensive as the LM itself, because it has to be at least like on par or even better than LM to actually be able to say that the reasoning process is correct or not. And the more problem, the more kind of big idea for them is that they don't really want to annotate a huge amount of training data, because actually you can imagine that if we want to do this process, we actually need to annotate a lot of reasoning data so that they can learn how human thinks about problem and so on. And they don't want to do that, so they give up on the idea, or they actually tried it and they didn't really have a lot of success on this verifying the process or the thinking process. So instead, they focus on the second part. So maybe I am allowed to reason a bit more freestyle. And what's more important is the answer. As long as I can get the answer correct, I'm good. So let's focus on the result. And there are a lot of tasks, the results are very easy to verify, right? Let's don't talk about like writing or some engineering tasks yet. Let's say if we have some kind of tasks that require reasoning process and very easy to verify, right? Yes, we can have a lot of tasks like this. We have a lot of mathematical reasoning problems. We have things like coding where we definitely need reasoning capability to answer those kind of questions. And it's very easy for us to verify. For example, we can compare the answer of math problems by just comparing the answers, the numbers. Or we can even use a compiler or to run some test cases of the generated program to say if the program, the coding is correct. So they focus on this part of data, then you don't need to provide any reasoning process. So the only thing that matters is the input and the output answer. Then another issue they're facing right now is, maybe if we think about it, the LM's output can be non-deterministic. Every time, right, if we want some interesting answer, we set a non-zero temperature, we ask LM, it gives different answer. If we only sample one answer, then maybe it will train the model towards something like the training will not be that stable. If we want to evaluate the internal weight of LMs, then we need another reward model, which is basically the thing we are trying to avoid so far. So what they developed or they adapted is this called group relative policy optimization, which is, let's say that we have this in-progress model and we answer it, we give it a simple question, a question that's simple to verify, which is the result of 1 + 1. The in-progress model, we sample it multiple times, it will give us multiple different answers, right? Some of them may be correct, some of them may be incorrect. And we have very easy way to verify it because we can just compare the output answer with the ground truth answer, like just by exact match. We can even give a score to each of these answers, right? We can develop basically a rule-based reward model, and we can say we have two answers that basically the one that we want, 2, right? Then we give a score of 100. Maybe we can use the distance between this answer to the correct answer or something similar to calculate some kind of score. Basically give each of these answer a score to rate how good it is. Like maybe it's 3, okay, it's a little off, we give a score of 60. The 42 is way too off, and then we give a score of 0. The idea of this group relative policy optimization is really just to take all those scores, compare which answer gets the highest score, and we encourage the model to output those this more frequently. Okay. Then they basically, with this, they can basically train this DeepSeek R1 model without any annotated reasoning process. So after, say, a long period of training, we finally got this R1 model. So they started to test this model. And this is the time where they observe this aha moment, and which I find very fascinating. Basically, if we ask it the LM question, it will start by thinking about something, and you can see how here it first start to just write down some think process, but at some point the model outputs, wait, there is a aha moment I have flag, we should probably evaluate this step by step. Maybe there is a mistake that I have made. So basically, this idea is that by just looking at this answer alone, focusing on evaluating the answer alone, and asking LM to think more freely, LM naturally developed the ability to evaluate its own solution during this reasoning process. And if you have tried DeepSeek model and looked at this reasoning process, you can see this thing actually happens very frequently when you ask it to answer some question. So we have this R1 zero model, which is great. So it can reason, it trained without any annotated reasoning process, but there are still some process where they flagged in their papers. So basically, even though this R1 zero is great, but the reasoning process can still be not very readable because we didn't really give it any clue of how to reason, right? So in some sense, some cases, like previously, it may have a readable reasoning where we can understand what's going on. But in a lot of cases, maybe it will just output some garbage or some random text that we can't really understand in the reasoning process. And it may also mix different languages because it didn't get the idea that it should reasoning consistently with one language. And this is very hard for humans to interpret and understand what's going on. And then what they started is, okay, then let's start over again from the beginning. But this time, we'll do some manual work to improve this R1 zero. So how they did it is, but we also have this R1 zero model, which we don't want to throw out. So what they do is that they use R1 zero model to generate basically generate a list of reasoning and answer process. They filter the ones that's readable. And here are some manual work that they still need to do. So they need to manually improve this reasoning process answer a little bit from this R1 zero model. And this produces them with some cold start data. Then let's start again from wave 3 base. Now we have more high quality reasoning data where partly generated by R1 zero, but also improved by humans. And this cold start data can help basically this wave 3 zero model to know what kind of reasoning process we are looking for. Basically, they use this cold start data to first supervise fine-tune this DeepSeek wave 3 model a little bit so that it gets the idea of what kind of reasoning process we are looking at. Then it basically do the same step as we did with DeepSeek R1 zero. So this whole reasoning-oriented reinforcement learning process we just described with R1 zero. But in this case, because it's supervised, now with reasoning, it tends to reason more like the reasoning process that we provided in this cold start data. And finally, but when we get this intermediate reasoning model, it's very good at reasoning and reasoning in the process we want. But still, in a lot of the cases, we are only training with tasks that's easy to verify, right? Like math or code. So at this point, the model is not yet good enough in general tasks like writing and so on. So that's why at the last stage, they also included this supervised reinforcement learning stage, where they start to use also some non-reasoning general purpose tasks, some data set for that. So to improve the model's capability in terms of the writing, creative writing, or say engineering tasks where the answer will be harder to verify. And of course, this stage, they also need to collect a lot of manually annotated data, but they can also reuse some of this DeepSeek R1 zero to generate some part of the data for them. So, and finally, they arrived at DeepSeek R1, and that's basically the model that created all this noise nowadays. So just to recap, what happened is they start with DeepSeek R1 base model, and of course they also have this supervised fine-tuned model that this DeepSeek wave 3, which is this chat model where you can also use in their web interface. They first use reasoning-oriented reinforcement learning to basically almost doing pure reinforcement learning to arrive some very impressive model called DeepSeek R1 0. So in this case, there is no human reasoning annotated data involved. But they find there are some problems like, okay, mixing of language or hard to read reasoning process. So they use this model to provide it, some cold start data for DeepSeek R1. Then they use this cold start data and to start again from DeepSeek V3 base. In this time, they use both reasoning-oriented reinforcement learning plus some supervised learning to derive this DeepSeek R1 that we see today. And what's more fascinating, they use some previous version of R1 to generate some distillation data for wave 3, so that they could also improve the ability of wave 3 after the R1 was created. And what's more crazy is they use this wave 3 again to generate some non-reasoning reinforcement learning data for R1. Remember that we talked about at the last of the stage that we already have a very good intermediate reason model, but this model is not yet very good at non-reasoning tasks like writing and so on. But the wave 3, because it's just like any chat LMs, is very good at those kind of tasks. So they use some previous version of wave 3 and again generated some non-reasoning reinforcement learning data to further improve R1. So they basically have this improvement cycle here, which I find very interesting. Of course, at the end, they also have this distillation where they take some open source models and try to distill some of this reasoning capability from DeepSeek R1 so that those models also learn to reason before they output the answer. Right, so this is basically a quick recap or idea on how they derived R1 from wave 3. So next, there are some quick discussions I want to do before we go to the general discussion period. So the first question you look at this, if you have been using LM so far, is what does it mean for us? If I want to use DeepSeek R1, what's maybe the first impact that may have on my project? Well, according to them, and also my personal experience, is your old prompt and techniques may actually no longer work with R1. They actually also stated in the data, in the paper, as you can see, that they find visual prompting consistently degrades its performance, which is basically contradicting what we are observing with chat-based LMs. So they actually only recommend that you to directly describe the problem and specify output format in a zero-shot set. So how to include, but in some cases, I can say that you still want to include some visual example, but how to include that visual example now is still an unknown problem. Previously, when we talk about this reinforcement learning process, we talk about, we use this example of 1+1. So now we know that we arrived at R1. So let's say if R1 can actually solve this problem. So this is the thinking process I gave to, R1 gives to me when I ask, what is the result of 1+1? Well, you may say it is maybe an overkill while thinking for 17 seconds before answering this question of 1+1. You can see there are actually some interesting thing going on. You can see that it starts to question itself, right? It may think, so at the beginning, it quickly derives, okay, at some point in binary, so it starts with thinking about different scenarios. Okay, in binary, this answer, it might be 10. In decimal, the answer is definitely 2, but maybe I'm tricking it. So it has, maybe the question is testing something else and start to think again, right? And it's basically thinking different scenarios where 1+1 makes sense. But at the end of the day, it says that, okay, the result is 2 because I assume that you're doing decimal. So if you read the last sentence, it's very fascinating that I guess there's no trick here. So it starts to think it's so much process. And then by summarize, it says, okay, maybe I'm not really tricking it. That's just output answer of 2. So this is good or bad, depending on, I guess, how you plan to use it. Of course, in some cases, overthinking is beneficial. You want the model to think more before it outputs its answer. So there are a lot of after the DeepSeek come out, there are a lot of open source projects that come up. One of them that I find very interesting is this DeepSeek R1 Overthinker, that you can, if you deploy your own DeepSeek R1 models, you can force it to think forever until you basically decided to stop. Of course, once it's output, because it's so cheap and it's incredible performance, the community also start to try to reproduce the entire pipeline. So if you're interested in that, you can look into this reproducing effort. It's called Open R1. And of course, you can try to use DeepSeek R1 yourself now with their web interface. And because it's open sourced, it's basically available in, I think, almost all major cloud provider like NVIDIA, Together.ai, or AWS. So you can, and also I guess Azure. So you can also use them on those cloud providers. Of course, because it's open source, you can actually also deploy them yourself. Of course, there are so many different variations of it. So I'm just trying to give you a basic idea of what's the relationship between them. So basically, by this reason, the number, if it's larger, it means that it's more capable, and which means that it's more expensive to host. The smallest model, in fact, you can actually host it in your phone. That you can actually try that. For things like 7 billion or 8 billion, you can probably host it with a single GPU, but with anything more than that, you probably need a large GPU cluster in order to host it and play around with it. And of course, if you're unfamiliar with LM hosting, you can try with Ollama or VRM to host them. All right, so that's a quick overview of what happened from Wave 3 to R1. So thank you very much. And so just some questions for maybe start with the discussion and for you to think about whether you plan to use R1 in your project, or what does it mean for current open source LMs? And maybe more interestingly is how will it impact the trend of the agentic AI? Because so far the agentic AI is mostly built on top of chat-based models. What is reasoning-based models would help or destroy us.
All right. Thank you so much, Percy. There is a lot of discussion going on in the chat, which I don't ask you to look at for now. We can look at it later. If anybody has any questions, please dump them in the chat and I will get to them quickly. Just to keep things less chaotic, I will be your voice. And we'll read out the questions, but I will also try to ask some of my own questions, and hopefully that will be your own questions too. So before doing that, I want to put this link again in the chat. We are going to have actually another session on R1. So Suhas, who's going to speak soon, has decided to change his topic to talking about R1 as well. So keep an eye on that page because we will announce it there soon. And I put the link to our Slack in the chat as well. So join the community if you are not part of it. With that out of the way, Percy, maybe we can go to the very beginning of your deck and slowly come forward, and I will ask my questions from there. I know Suhas is going to talk quite a bit about the V3, but maybe can you just very quickly in a few sentences recap what's the relevance of V3 to everything that you talked about? Just maybe recap that part quickly.
Yeah, so basically V3 is, as you can see from this image, V3 is this basically the base for DeepSeek R1. So they start, when they train DeepSeek R1 series of models, they start from DeepSeek V3. So they didn't start with a purely random initialization. So they start with V3 base, which already is by itself very powerful. And in a lot of tricks that people now talk about, that which makes it so efficient, so cheap, that didn't really happen in R1. It happens in V3. Right. So things like also in the overview, like a mixture of experts, the multi-layer latent attention, and floating point 8 training, all those things actually already happened at the point of V3. So V3 is actually already an extremely cheap and efficient model. And they did a very great job on top of that to create a reasoning model. And that's not R1 that we're looking at right now. And it's also open source. So all the DeepSeek model families are open source, and you can check them on Hugging Face and download them.
Yeah, again, like that, I'm not surprised that Suhas is very excited about V3 more specifically, and he wants to talk about it because a lot of the interesting things that we talk about in terms of R1 actually is V3 properties. In terms of maybe to give us a point of comparison, which open source model or black box ones out there are most similar to what V3 does?
So V3 is not like by itself, the capability itself is no different from most of other open source LMs like Llama or QN or those kind of models, or even say a closed source like GPT-4o and so on. The more thing that people are interested about is basically its capability, its efficiency, and so yeah.
Okay, great. So I can think about it as, say, I don't know, 4.0 or something like that, or Llama 3, but a little more efficient in terms of.
Yeah, exactly. But it's also, of course, it's also an MOE model, which most of the open source models are not mixture of expert like Llama and so on. They're so-called dense model, which means every time you call it, all of the neurons has to basically be activated to answer your query. But this mixture of expert models means that you can only part of the activations are activated. So DeepSeek R1, for example, I think it's claimed to be about 600, or even V3, it's about 600 billion parameters. But for it to answer, to generate the next token every time, only around 30 billion tokens are activated, which means that though it's very hard to host because it's very large, it has a very strong memory requirement, the inference is very fast because only around 30 billion parameters are activated. So in some sense, I think the last mixture of expert model we saw was, if I remember correctly, it was, I think, Mistra. But afterwards, there wasn't really a lot of updates on this mixture of expert models.
I know Mistral also dropped the model yesterday, was it? So anyway, we're not talking about that. So then from DeepSeek V3, they created R10. And this is a model that is trained in an unsupervised way. Is that correct?
Right. So that's it's partially correct.
Okay.
So and that's also the first. So of course, you still need data. You still need to answer the question and answer. So in some sense, you still need some annotated data. But the fascinating part is you somehow the model learns the intermediate steps by just looking at these two things. And I think very interestingly, what happened was this wasn't something new. So by just looking at the input and output pairs, enable the model to learn the intermediate steps. I think people has already been tried since ChatGPT came out. So they also a lot of effort on this, but there was no success. And actually, it was because of failure before, and people started to use the process reward model. People started saying, "Oh, I couldn't get anything from input-output pairs, so I have to focus on how model reasons." So that's why the process reward model came out. And the really good contribution of DeepSeek R10 is actually showed this is possible, right? Because all those effort was not successful, but they showed one successful example, where the model actually learns how to reason just from input-output pairs.
Right.
And I think that actually helped the research community a lot.
Right. If you don't mind, please put your question in the chat, and I'll try to pick it up from there just to reduce to make things more efficient. So I want to understand that a little more, because when I see this for the very first time, I was like, well, this is process supervision. We knew about it already. So what is so surprising? And in process supervision or thinking LLMs, I think thinking LLMs paper was following a similar pattern. As you said, like essentially, not only we look at the beginning and the end, but we also look at the intermediate steps. And the reward functions are specifically also tailored to look at intermediate steps and make sure that the intermediate steps are also correct, as opposed to output supervision, which is only, here's the question, here's the answer, is the answer correct or not, regardless of how you got there. So you're saying that they managed to figure out a way to bypass the process.
Right.
So
exactly.
Why do you think that's the case? Like, how did that happen? Like, it sounds like magic.
Yeah, that's honestly, that's the magic to me. I think if we go back to some of the slides, I think some of the factors that, of course, I'm not from DeepSeek. I don't really know the full picture yet. And I think people are still trying to reproduce and to see which is actually aspect that helped with this process. I think one of the very important part is this group-related policy optimization, which you don't only look at one answer, but you look at multiple answers from so that you actually give it a more holistic feedback on how the model performs. Because one of the problem with output supervision was exactly that LMs has this uncertainty, like uncertainty in a good way that we want to have. But if you just look at one answer, then the training process will be very unstable, because it might just get that answer by luck. But by looking at the set of answers, you get a more holistic view of how this LM performs and able to give you the better feedback on the current status. So that's, I think, one factor I feel that can be very important in this case.
Okay.
Yeah.
Sorry, go on.
Yeah, of course. I also think but it's more like a hypothesis or thought that I found maybe reasonable, which is when people first tried this output supervision, that was about 1-2 years ago. At that point, chain of thought just came out. People were still very hyped about it. And there was not that a lot of information on this idea of reasoning on the internet. But now at this time of DeepSeek, when they collect their training data for DeepSeek V3, there are a lot of examples of chain of thought already on the internet. So in some sense, all of us, if you posted something about chain of thought, may actually contribute to this trend, because by looking at all those newly emerged data from the internet related to chain of thought and reasoning, maybe V3 by itself already had some capability of reasoning, and that's why we don't really need to further supervise it to reason, but just to focus on output for it to create the correct reasoning process. But this is more like hypothesis. So.
Yeah, that's definitely very interesting. I wonder, is this true that they only looked at very heavily verifiable fields like mathematics and coding only? Like, did they do anything outside of those?
Right. So for DeepSeek R1 I think those are the ones they focused on. Partly because if you want to focus on output, so the reason they focus on output, one is that they want to explore if this is possible, because they had a failure with process supervision. They wanted to say if output supervision is possible. Another is they want to also make the training efficient, right? So that's why they choose, if you look at their reward model is really just rule-based.
Yeah.
There is no crazy neural network that calculates the reward. So that's why they focus on tasks that's easy to verify, like math with numbers or code, where you can just run some test cases. It may be possible to also add more sophisticated and hard to verify tasks, but that may actually require another reward model to calculate the reward, which kind of like contradict with why they went to this output supervision.
Yeah, that was my reading too, that most probably what they did was for the zero, they focused more specifically on things where providing feedback to the agent, if you wish, is more straightforward, because is it the correct math or not? Usually it is relatively easy to figure out, is it the right code or not. That, in comparison with, I don't know, reasoning in physics or reasoning in business context or whatever else that might be necessary, so that the model R10 learn the mechanics of reasoning rather than any specific pattern of reasoning from data. And then in training R1, they try to generalize that a little more.
Yeah, exactly.
I read this piece, I think it was from J.L. Amar, who was saying that his expectation is that these will be very good reasoning models for very specific fields. But as soon as you start going outside of those might fail. But at least there is a recipe that then now we can start repeating it in other areas, maybe even combining with process supervision and things like that to apply it to other types of reasoning.
Exactly. And also, it's not also the DeepSeek R1 model is also open source. So at some point, I haven't really tried it, but at some point it'd be interesting to actually check what their output in those kind of tasks.
Yeah, and actually another thing that gives me a bit of intuition for saying that DeepSeek Zero only learns the mechanics of reasoning is that its output is completely unreadable or largely unreadable, right? So it is sort of coming up with its own, reasoning language and mechanics, but then to turn it into more readable language, they have to do the process that you're showing now, which is now retrain it to become, more readable, focused on one language, blah, blah, blah.
Right.
Okay. There were some good questions in the chat. Let me see if I can remember them. One of them was from Sahar, who was asking, on one of your slides, you said that they took a very long time to train. Was it the model 0, I think?
Yeah.
So what does large scale mean here? Like how long are we talking about? How much resources do you know that?
They didn't really talk too much about the resource they used to train R1, nor the time they spent on R1. Yeah, but I just just put this one because you expect it to be long. But for the exact number, I don't really have that information.
Okay. Let me see what other questions I missed. If you asked a really good question and I missed it, please put it in the chat again so that it comes down to the bottom and I can see it. Somebody's asking about the slides and recording. Slides will be on a Slack. The link to a Slack is pinned in the chat. The recording will be on YouTube. The link to YouTube is pinned in the chat. So if you scroll up, you will see both. What are DeepSeek's implications for enterprise and startups? Let's get to that question at the end. So maybe let's just spend a few minutes talking about the practical steps. So because there are a bunch of people on this call, they might want to play around with it. So I know you mentioned a few things like, Olama, VLLM, and such, but, let's say somebody wants to get it started. Like just, maybe provide the step-by-step process. Like where do they go? What do they use? What can they do on a typical machine? I know you went through it, but you went through it really fast. So just maybe a quick recap would be helpful.
Yeah, so basically everything with DeepSeek is every models that DeepSeek has built is open source. So you can go to Hugging Face or to just deploy it, to just find them out. And I think for things like Olama, if you want to host the model, it's very easy. Like I can actually go to the website, right? So if you download it and you just call Olama run DeepSeek R1. That's it. Of course, don't try to run 600 billion model on your laptop. And you can check there are other options like 1.5, 7, or 8B. So you can check the model size and compare it with the GPU that you have. Of course, you can also host it with CPU, but that would be very slow. So for things like this, you can mostly host it like up to 714B. You can pre-host it with a consumer grade GPU. And up with that, maybe it will be easier if you go with a cloud provider to use their endpoint or deploy there. If you don't have the equipment, right? If you have the equipment, then yes, you can just deploy it.
Okay. Well, hopefully that's helpful for anybody who wants to give this a try. The last question, and then we'll stop the recording and probably do a bit of an open-ended discussion. The role of annotators to go from 0 to 1 is obviously very important, because the annotators probably provided a bunch of important nuances that 0 was missing. What do we know about the annotators? Are they like mathematicians and software developers? Are they random people from the street? What did they share about the annotators?
Yeah. Unfortunately, DeepSeek has revealed a lot of information of their model, but that was not part of it. So what they said was, in this part, they generated a lot of reasoning data with DeepSeek R1 0.
Yep.
And they filtered the readable ones. I guess that would be a manual filtering as well. Then for the readable ones, they say they just improve it. That's it. So thankfully, we have this kind of open source reproducing effort like OpenR1. So I guess give them a couple more months, then we'll probably say how this was done.
Right. Also, to make sure this is a text-only model, right? Like it's not a multimodal.
Right. This one is not a multimodal one. It only works on text.
Okay. Fantastic. This is the end of our formal session, because we are very close to an hour. I'm just going to put some links in the chat quickly. Keep an eye on this link for more presentations like this, and join our Slack here. We will post the slides there. There's also on the announcements channel, there is a discount code for our course on building multi-agent applications, and a bunch of the folks that are on the call are from that course, from that bootcamp, and they're actually using DeepSeek in their projects. So if you want to do something like that, today is the last day for early bird for exclusive for ACE members. So take a look at that. And the link to YouTube, let me also put that quickly, where the recordings will be. And with that, recording. Thank you so much, Percy.
Thank you.
You also